Greetings everyone, this is non-expert here, back again with another video. Today we are going to be solving problem number 54 and the difficulty it's rated at is hard. This problem was asked by Dropbox and let's just get down to the problem description. So Sudoku is a puzzle where you're given a partially filled 9 by 9 grid with digits. The objective is to fill the grid with the constraint that every row, column and box, which is a 3 by 3 subgrid, contain of the digits from 1 to 9. And all we need to do is we need to implement an efficient Sudoku solver. So cool. So if you know what Sudoku is, this is going to be really helpful for you. But if you don't know it, all you need to worry about is the fact that you understand what the constraints are. And fortunately, we were able to find a similar problem on LeetCode, and the name of the problem is Sudoku Solver. As you can see, the difficulty has been rated at is hard over here as well. And I would urge you, as usual, that you pause this video and check out the link given in the description below and try solving this problem on your own. So as you can see over here, it's sort of defined all the rules, which are each of the digits from 1 to 9 must occur exactly once in each row, same thing for each column, and also inside your grid. So basically, if you sort of look at this particular Sudoku puzzle, which they're given, you can see for the fact that, this is your box and these are your rows. So basically, if you want to assign one over here, you want to make sure that, one does not occur in the row or the column. So occur in the column, it should not occur in this row, and should not occur inside this box. If it does not, then you can sort of put it and then you can go forward from there. So as you can sort of think about, as I'm talking about this approach, you can think for a fact that this is more like a backtracking problem, and it is. And the way we're going to go about it is we're going to check whether the value that, we're going to first iterate from 1 to 9, and as we're iterating, we'll try to push in those values. And if the value is safe and the safeness of value can be determined by these rules, um, if it is safe, then we sort of push in that value inside our board, and then we sort of recursively call so that we check whether it can eventually lead to a correct result or not. And if it does, then awesome. Otherwise, we sort of return that value back, and then we sort of go about it from there. So basically, you go from assigning values one by one, and then you move forward from there. I sort of already explained the backtracking approach in my previous videos, so I sort of urge you to sort of check it out over there. But let's just get down to a solution. So we're going to start with a base condition as we usually do. That, hey, if nothing has been given into boards, then we just return a none. And what I'm going to do is I'm just going to assign a variable called board and assign it to the self value so that's available to me across all the functions. And specifically for this approach, where there are multiple functions that you usually find, or whether there are too many rules, and for a fact that you're going to use backtracking, I would urge you to sort of break it down into multiple functions, and that's basically the way to go about it. And if you feel like there's a function or there's a variable that you're going to be using a lot, I would just urge you to just assign it as a variable like self.board, just because it sort of acts as a global variable, and then you can move forward from there. By global variable, I mean that you can access that value in any of the functions. Cool. So all you want to do over here is you just want to call some function. I'm just going to give it a name called solve, and let's just write solve. So solve is not going to take in many parameters. All it's going to do is it's just going to be recursively called over and over again. And what we want to do now is we want to check whether, also let's just break this down by commits, right? So the first thing that we want to do is we want to find an unassigned variable. And the way to do that is basically you can do a simple iteration just to check for the values with an empty cell indicator. Over here in the problem statement, we have been given that an empty cell has been defined or has been indicated by a character full stop. So basically, or dot, whatever you want to call it, right? So what we're going to do is we're going to check for this value. So the first thing is that we find an unassigned value. And this guy is going to help us understand whether we assigned all the values or not. Right? If all the values have already been assigned, that would basically mean that we've probably gone through all the cases and everything has been sufficed, all the rules are correct, and then we move forward from there. The next approach would be just to do a simple iteration, and we do an iteration from 1 to 9, and this is just so that we can sort of place that value and apply rules on it. So we iterate from 1 to 9 and apply rules on it, and if the rules are sufficed, then if the rules are sufficed, then we sort of recursively call that function, and then we sort of go through the backtracking approach, right? So I know that these comments don't make sense right now too much for many of you, but let's just write it down. So what we're going to do is we're just going to break it down, each of these statements into a function, or at least we'll try to. And what we're going to do is we're going to say that the first thing that we have to do is we just have to look for an unassigned variable. So what we can do is we can just make a function, and let's just call it def find unassigned. And all we're doing over here is that we're just going to iterate from 0 to 8, just because the indexes of the values are from 0 to 8, and we know for a fact a Sudoku puzzle is a 9 by 9 grid. I mean, at least for this question, right? So we just say for row in range from 9, which is going just to give me indexes from 0 to 8, and same thing for all the columns from range 9 till range 9 rather, which is also 0 to 8. We just check for each and every single value one by one. Oops. So we just check for each and every single value that we have, and what we're going to check for is whether it is a dot. And again, a dot sort of represents whether it's an empty cell or not. So if it's a dot, then it is an empty cell, and what we're going to do is we're going to return the row as well as the column. And if this thing does not return anything, then we just return a -1, -1. So what's happening over here is that either a row and column will be given, or a -1 and -1 value will be given. And over here I'm returning two values, and that's something that you can do, so that I can just call row column and just say self dot find assign. And if you don't know what's happening this here, it's basically tuple and packing. Basically this function is returning two values, and you can set those values like this. So row sort of coincides with this row, and the column sort of coincides with this column. And one thing which is sort of sorry, sort of wrote this wrong. Let me just copy paste this so that I don't make any redundant mistakes. And what's more important over here is that this sort of helps us make a breakout condition as well. And a breakout condition is just going to be, hey, if our row column is equal to -1 and -1. And if that is the case, that means that we found a particular case where we've assigned a value to each of those values as well, or each value has been, or the Sudoku puzzle has been finished. So in that case, we just return a true. And this return value is a Boolean value which we're going to be using inside a solve function, and we're recursively calling it in a backtracking approach as well. A bunch of words, but let's just get down to it with iteration now. So iteration is going to be very, very simple. So all you need to do is you just need to make sure that you're iterating from 1 to 9, or in our case 1 to 10. So you know for a fact that 10 is going to be the limit, and this is going to return the value from 1 to 9. But what's more important over here is the fact that the way they represented values inside our board, each element is sort of represented as a string. So you want to make comparisons from that. So what we're going to do is we're going to use a higher order function called map, and we're going to convert each of these values inside this list, or each element inside this list, into a string. So again, if you didn't understand what's happening over here, this is basically going to return a value from 1 to 9, and each value, each element is basically going to be a string representation. And then we're going to move on from there, and that's what this str is doing. If you don't know what a map is, I would suggest that you Google it. It's pretty simple. It just takes in a few variables. The first variable, the important variable, is function, which sort of updates, or sort of updates a particular element. And next value is just an iterator, and that's something that you can just pass in. But I'm not going to get into that. It's just something that you want to make sure of. And now all we want to do is we want to make sure that the rules which have been given have been applied properly. So we can just make another function. I'll just call it is save for now, and it's going to take the row, the column, and the number. And let's just write pass for now. And the reason why I'm writing it like this is just because you would sort of want to break it down. So isSafe is just going to be a function which we're going to define right now. And what we want to check is whether the row is the correct row, or rather inside this row there are no other elements which have the same character. Same thing sort of goes for the number as well, and the same thing sort of goes for the subgrid as well, right? So what we're going to do is we're just going to make a variable. We're just going to call row safe, and what I'm going to do is I'm going to use a all function, and all function inside Python is just basically a simple function which can be used, which takes in an iterator, and what it does is it sort of returns a Boolean value. right? And the way it sort of works is that let's say that you've pushed in true and true as a list. So if all the elements are true, it returns a true. But if any of the elements is false, then it returns a false. So it sort of checks whether all the values are true or not, and that's something that we're going to be using. And we're going to be sorry, we're going to be using more like a list comprehension or a generator comprehension sort of a way. So all we're going to do is we're just going to say for underscore in range, and now what we're going to do is we're going to check for each and every single and we're just going to check whether this row is safe or not, right? So the way to do that is just like you write self sorry self board, the row has already been defined, so you check whether this row has this row is completely fine with this character. What that means is that this character does not exist inside this row. So the way to do that is basically do an iteration and just basically do a check. And if you don't understand what's happening over here, it's just a simple list comprehension way of sort of writing it. Just for brevity and conciseness, I'm just using this. So you're doing it from 0 to 8, and that's the indexes, and you're checking for the row which we've selected, or where we know that there's an unassigned element. And what we're going to do is we're going to make sure that that row does not have the character which we've already defined. So the value 1 to 9, we're just checking whether 1 to 9 exists or not. And a similar approach, that's something that we're going to be using for the columns as well. So we're going to check whether this column is safe, and all we have to do is we just have to update the row and columns. So that's basically it. This is just going to check for each row inside this particular column whether there is any other element already there. So if you didn't understand this, you can check it out over here. So if you have one over here, what's going to happen is it's going to check for all the values, all the column values inside this row, whether this row is clean or not. By clean, I mean whether there's any other element as one over here, and the same thing over here for column safe. So that's just the way to go about it. And the next thing is that we want to make sure that our subgrid or our box, which is sort of defined over here, whether that's safe or not, or rather if I'm putting in a value, whether there is no other value inside that. So I'm just going to define a function before I do that, and the function is just going to be a get range function. I'm using this get range function just because of the simple fact that usually what happens is you want to make sure that you get the top element. So if you have a row 2 and column 0, we know for a fact we need to go from a row 0 to 0 and then just do +3 from there. So what I'm going to do is I'm just going to use the modulus function to get the remainder, and I know that each box is divided as a 3 by 3 matrix, and we're just going to leverage that. So let us do that. Let's just say that the x value which has been given needs to be divided by x divided by 3, and what this does is sort of returns back the upper limit or the upper value which is divisible by 3. And all I want to do is now I just want to return a range from x to x plus 3. So this thing will be used for both rows and columns, and then we're going to use that in order to make sure that our square is safe or not. So square safe is a variable that we're sort of defining over here, and the way we're going to go about it is that we're going to go from all the columns, all the rows, and all the values, all those 3 by 3 matrix, all those 9 values are going to be compared in as we go about it, right? So let's do that. Just say for r in self dot get range, and all we're doing is just returning row because we know that's the row that we want, and the same thing for the column. So self dot get range column, all we're going to do is, since we're using a list comprehension way of writing it, all we're going to do is we're just going to say the self dot board and the row and the column that we sort of computed or computed through the for loop, whether there is any value which is equal to ch or not. So whether this is true or not, if it is true, then all is going to return true as well, and that basically means that the square is safe. So all you're doing over here, you can sort of break it down into several for loops as well, but I just want to write it as in with as much conciseness as I can. And all you want to do now is you just want to return row safe, column safe, and square safe. So basically you want to make sure that all these values, all these conditions that we sort of define, whether all of them are correct or not. And now we're going to use the self is safe function, which we've already done, and it's going to return a true value if it is safe. And if it is safe, what we're going to do is we're just going to use our backtracking approach now. So all you want to do is you just want to set a value, a number value to your row and column. And now what you want to do is you want to recursively call your solve function. So the function that you're presently on, you want to recursively call it. And you know for a fact that it's going to return a true if all the values have been assigned. And if it is true, then it return true over here as well. So the way the call stack is going to go is you're going to make multiple recursive calls, and all the values, they're going to have to make sure that you return some value over there. And if you return a true, that's going to help us understand that, hey, this particular value is correct, and it does lead to a correct solution. But if it's not correct, all we want to do is we just want to update it. So let me just copy paste this and push it down below. And all you want to do is you want to make sure that you return it back to its original state, which was a dot. And that's the way you're going to go about it. All you're doing over here is that you're just making sure that you're using a backtracking approach, where you're board or the Sudoku puzzle by assigning a number one by one to the empty cells. And that's just before you make sure that it's safe or not. And as you go about it, we are just basically checking whether each current row, each current column, or each current grid, all of those things are safe. And if it is safe, you're just using the backtracking approach to assign the value one by one, and then you move forward from there. And that's basically it. There's nothing more over here to be done. And let's just run this. Hopefully this should run fine. I see that I've sort of written board somewhere, and that's my mistake. Let me just check it real quick. Where have I written it like that? The first line itself. I apologize for that. Let me just run this again. We are getting an error. That's just because the isSafe function hasn't correctly. So let me just write the self as well as update the number as well to the character representation that we sort of expecting it to be returned. And just basically run this one more time. Hopefully this should run now. I apologize for that. Somehow in the mix of it, I sort of forgot to write the self and update the number value. And cool, I'm pretty sure that you cannot understand whether this is running fine or not, but I can assure you that it is. And you just have to take my word for it. But let's just go ahead and submit the solution, right? And hopefully this should get submitted. And awesome, you can see that's running fine. It's not the most fastest solution, and there's a reason behind it. It's just because of the backtracking approach and the number of for loops that you're doing, and you can reduce all these things just by using a set representation or dict representation. But that's not the gist of it. An interviewer is not going to expect you to come up with the most optimal approach. They're just going to worry about how you're handling the is safe condition and how you're handling the backtracking. And that's basically it. There's nothing more here to it. And if you have any problems, if you have any comments, do leave it in the comment section below. If you have any queries, I would love to handle any of your queries. And if you did like this video, do give a like and do subscribe to the channel. We are a discussion over here, and we would love to have you on board with us. And if you've already subscribed, you're awesome. We all know it, and have an awesome day. Thank you.